In the last lecture, we have seen the Pearson coefficient, and we have solved some problems based on that. Okay, so we have solved the problem based on the raw data. So the data was given to us, and then we calculate each and everything, and then we were able to get the coefficient of correlation, precisely the Carl Pearson coefficient of correlation. Now, sometimes the data is already processed, okay, with some assumptions, okay, and then if the data is processed with the assumptions, then we have to find out the Carl Pearson coefficient for correlation. Okay, so let us see what happens if the data is already processed, semi-processed, we can say, the process with the assumption. Okay, and what are those assumptions? So in the previous examples, we have calculated mean actually. Okay, so we have the sum of all the X series and Y series, and then we calculated the X bar and Y bar, and then used that. Now, suppose without calculating the X bar and Y bar, directly the data is given to you. Okay, or it is calculated with some assumed mean, then what? Okay, so we have to process such data. So let us see some examples based on this kind of processed data, how we are able to get the Carl Pearson coefficient of correlation. Okay. So before we go to the Carl Pearson coefficient on the process data, okay, we'll see first a remark that we need to understand. Okay, and then we'll have uh, the process data, and then using that process data, we'll try to find out the solution. Okay, so first you need to write this remark. Okay, as we are done with the unprocessed data, the raw data. Okay, and now what we have here, suppose we have X bar is equal to A plus summation small x upon n, where small x is x minus A, and A is obtained by replacing the actual mean. So this is the deviation from the assumed mean. Okay, small x is the deviation from the assumed mean. Up here we have considered it is as a mean deviation. So here small this capital A is a assumed mean, and capital B is a assumed mean for this Y series. And now using these two equations, X bar is equal to and Y bar is equal to, and these relations, we are able to find out the summation of this small x and summation of this small y. And once we know the summation of small x and small y, we are able to use the formula. Okay, so what is the formula we have? Okay, so if we have a assumed mean, then we have the formula. Okay, so the Carl Pearson's coefficient of correlation R is given as, okay, so what you'll be having, R is equal to, see, the formula here will slightly change, x into y, summation x into summation y. Okay, and here we have square root of n into summation x square minus summation x square into square root of n into summation y square minus summation y bracket square. Okay, so this is the formula we have for the assumed mean or the data when we have calculated all the terms with assumed mean. Okay, now the question is this formula and the formula earlier given to you is same? Yes, it is same. Okay, so how? Okay, see when we have, okay, so if a is equal to x bar and y we have b is equal to y bar. Okay, so if x is equal to x bar and b is equal to y bar, that means instead of the assumed mean, I am taking the actual mean. So if we take the actual mean, what will happen? So x bar is equal to a, and here y bar is equal to b. So that's why this term will cancel each other, and then you'll be having summation x is equal to 0 and summation y is equal to 0. So here this will imply, okay, so this implies summation x is equal to 0 and summation y is equal to 0. So summation x is equal to 0, y is equal to 0. That means this term turns out to be 0. This is going to be 0. This is going to be 0. So what will remain in this formula? See, so you will have r is equal to n times summation xy. And here you have square root of n times summation x square root of n times summation y square. So you can have this n times summation xy, and you'll be having here root n times summation root of summation x square root n times summation. Okay, so what we'll get here? So this is root n time. Then we have this is root of summation. Okay, so it is going to be root of summation y square. Now this root n and this root n will become n, and this n will get cancelled, and you will be having summation xy upon square root of summation x square into square root of summation y square. This is the earlier formula that I have given to you. Okay, so this is what I have given to you. R is equal to, okay, summation x into y upon square root of summation x square into square root of summation y square. So you can see this formula and this formula is exactly same with these conditions. Okay, so if I assume that the assumed mean is equal to the actual mean, then these terms will be 0 and your formula will reduce to this. Okay, if your assumed mean and the actual mean, these two are different, then you will have this formula. Okay, so that's why we have to be careful while using the formula. So we are going to use the assumed mean, or we are going to use the actual mean. So in the previous examples, okay, I have used the actual mean. Okay, but sometimes the data is processed with the assumed mean, and if the data is processed with the assumed mean, then we have to use this formula. So remember that if you use actual mean, summation x will go 0 and summation small y will go 0. If you use assume mean, then this will be a non-zero term. Okay, and that we have to see in this lecture. So let us see how we are able to get this. Okay, so I hope you have written this. So are you written this one, this remark and this formula? Yeah, that's good. Okay, so let us see the examples based on this. I hope you are having the calculators with you. Okay, so let us see an example. So write down this example. So we can have here, this may be your Next example 4, 10. So write down the example. You can see a computer while calculating the coefficient of correction between the two variables x and y from 20 observations obtained the following results. Okay, so computer has already obtained the results. So that means this is a process data. Okay, and the process data is n is equal to 20, summation x is equal to 100, summation y is equal to 75, summation x square is equal to 625, summation y square is equal to 610, and summation xy is equal to 496, where x and y are the deviations from the means of x bar, x and y. So find out the value of r. Here we have to find out the value of r. So already the data is processed, but we have to draw the final conclusion. Okay, so what we can have is then we have, so we'll write all the given things. So we have n is equal to 20. Then what is given? Summation x is equal to 100. Summation y is equal to 75. Then we have summation x square is equal to 625. And we have summation y square is equal to 610. And we have summation xy is equal to 496. Okay, so you can see all the terms that are required in this formula are already given to us. So we don't have to make the table here. Okay, already the data is pre-processed. Okay, so we have obtained this result. These terms we have already obtained. Okay, so table has been made and then the calculations were done. And then we got these summations. So we just have to use this summation in this formula to calculate the coefficient of correlation. And so we write here the coefficient of correlation. Okay, small r between x and y is given as. So what is r given as? So it is n times summation xy minus summation x into summation y upon, what is the term we have here? Square root of n times summation x square minus summation x bracket square upon n times summation y square minus summation y bracket square. Okay, so this is the formula. Write down the terms. So it is 20 times 496 minus, so it is 100 times 75, and we have here this square root of, so what we have here 20 times summation x 625 minus 100 square into we have square root of 20 times 610 minus we have square of 75. Okay, so this is the value of r. So you please calculate and then tell me what is the value of r you are getting. So please calculate this value, what you are able to get. So whenever you have small x, summation of small x and summation of small y is non-zero, that means the computer has used the assumed mean method. So here in this case, this is done by the computer. So computer has used already the assumed mean method, and so we have to use this formula. So we are using the formula for the assumed mean method, and then we got the value of r. So you please calculate and tell me what is the value of r. Yeah, That's good. So many of you have got the value. That's good. Kalyani, Ishika, Ayushi, Rudransh, Pakshal. Good. Okay. So the value you got is 5968. Okay. So 0.5968. Okay. So you got here that's equal to 0.5968. So you got 0.5968. Okay. So we got this value, hence we can write is the coefficient of correlation between x and y. Okay, so that's what we have. Okay, so simple. This was very simple example. Already the data is processed and given to you, and then you just have to use the formula for the assessment method, and then you are done with this example. So the easy example. Right. So do you have any doubt in this example? Okay, that's great. So we'll have the one more another example. Okay. So I hope this is visible. Okay. So we can have the next example. Right. Okay. Now you can see calculate the correlation coefficient between x and y from the following data. Okay. So we go with the solution, and you can see here x minus a and x minus y minus b. Okay. So as given in the remark, okay, you can see uh, the remark what I have small x is equal to capital X minus a and small y is equal to capital Y minus b. So from these two equations, we have to get the value of a and b. And hence, in this example, you can see it is going to be this is small x and this is small y. So we got small x is equal to x minus a and small y is equal to y minus b. So we got the value of a is going to be 12 and b is going to be 13. Okay, so what we have here, how we are able to solve the problem. So let what is n given here? N is equal to 8. Always write the given data. Okay, so summation, please be careful for the small x and capital X. Okay, so small x is given to be 120. Summation, capital Y is given to be 136. Okay, and what we know is uh, x bar. So capital X bar is equal to summation capital X upon n, and what we know is y bar is equal to summation capital Y upon n. Okay, also what is given? It is given so summation, okay, summation capital X minus 12 square is equal to 160. So this is actually what summation small x square. Since what we assume is summation small x is equal to capital X minus 12, and what you'll be having summation capital Y minus 13 bracket square is equal to 201. So this is summation small x small y square. So small y is equal to capital Y minus 13. Okay. And now what this is going to be? This is going to be summation small x into y. So we have here summation x minus 12 into y minus 13 is equal to 15. So it is summation x into y. Okay. And now what is missing? You can guess. Summation x is missing and summation small x is missing and summation small y is missing. And that's what we have to calculate first. Okay. So how we are able to calculate this? By using the remark what we have here. Okay. So this is the formula that we have to use, and this is the formula that we have to use to find the summation of small x and summation of small y. Okay, so let us try this. Hence, we have what we know is x bar is equal to a plus summation x upon n, and what we know is y bar is equal to b plus summation y upon n. Okay, so what we know is here n is equal to 8, okay, a is equal to 12, and b is equal to 13. Okay, so what we can have x bar is summation x upon n. This is equal to a plus summation small x upon n, and we have this is summation y bar upon n, and this is b plus summation y upon n. So let us put these values. So what do you have here? Summation x is given. Okay. So what is the value of summation x is given 120, and this is going to be 136. Okay. So we have this is 120 upon 8 is equal to this is going to be 10. So a is going to be 12. Okay, plus summation x we want to find out, and here we have 8, and this is going to be 136 by 8. This is 13 plus summation y upon 8. Now these are very simple equations to solve. So we can have 120 is equal to 8 into 12 plus summation x, and we have 136 is equal to 8 into 13 plus summation y. I want you to solve this equations and tell me what is the summation of x and summation of y. So please solve this and get these values. Yeah. You have to get a value of summation of small x and summation of small y. So you please calculate and give me the value. What you get? Akshal got the value. Ishika also got. What about the others? Lenny also got it. Good. What about the others? I hope others are also doing. Bhavesh also got. Good. Ayushi, Rudransh, Anushka, Shailendra. That's good. Adesh. Okay. So you got the value. So that's going to be 24 and 32. That's great. Okay. So let's go ahead. Good. You got the value. Good, Arjun. Okay. So you got this is going to be 24 and this is going to be 32. Okay. So once you got these values, okay. So these were the missing values to use the formula. And now we calculated the missing values for using the formula. So now all the values are with us. So we have n, we are having summation x square, we are having summation y square, we are having summation xy, and even now we have calculated summation x and summation y. Okay, and hence we are able to write the formula and we are able to calculate the coefficient of correlation. So we can write the coefficient of correlation between x and y is, so what is the formula? This is the assumed mean method, so we have to be careful. N is equal to summation xy minus. So we have summation x, summation y upon. What is the formula we have? Square root of n times summation x square minus summation x is square, and then again we have for y. So n times summation y square minus summation y and x square. Okay. So we got all the values here, and hence we'll use that values. So R is equal to 8 times summation xy. So what we have this value. Okay. So let us see what is the value of summation x into y. So it is going to be 50. Okay. So we have this value is 50 minus this is going to be 24. Okay. So this 24 and this is 32. Okay. Upon what do you have is the square root of 8 into summation x square. So what is the summation x square? It's going to be 160. Okay. So summation x square is 160 minus this is 24 square. Okay. Then we have for y term. So it is square root of 8 into 201 and minus summation y square. So it is 32 square. Okay, so that's what we have. And now you calculate this value. So calculate this value of R and then give me the value what you get. Okay, it's great. Satvik got the value first, then Pakshal, Ishika, Kalani, Rudransh. Okay, what about others? Yeah. Ayushi also got it. Bharat, Ratamesh, yeah, Bhavesh, that's good. So you got the value minus 0.5739. Okay, so we got the value. Okay, that is going to be this is minus minus 0.5739. So we got the value R is equal to minus 0.5739. So one thing you might have observed that all the values of R are in between minus 1 to 1. Okay. So this value will never go less than minus 1 and never go more than 1. Okay. That's what we have. So we can say is the coefficient of correlation. Correlation between x. Okay. So that's where we are able to get the coefficient of correlation. Do you have any doubt in this example? So hope you are enjoying solving the examples. Okay. So do you have any doubt? Okay, that's great. Good. Okay. So let us try one more example and then we'll move to the rank. Okay. So we have the example 6 now. Calculate the correlation coefficient between x and y from the following data, which is very similar to the previous example. Okay, so let's go with the solution. So what we have here, let n is equal to 10 Okay, summation capital X is equal to 25. Summation capital Y is equal to 189. Then we have we have here. Okay, so summation. Okay, what is the term you will be having? Summation X minus 22. So please be careful while writing the small x and capital X. Okay, so all our variables are capital, but we are converting them to small. So this capital X bracket square, capital X minus 22 bracket square is equal to 85, which is precisely summation x square, where x is capital X minus 22, and summation y minus 19 square is equal to 25. So this is summation y square, where we have small y is equal to capital Y minus 19. And then we have summation, okay, x minus 22, y minus 19 is equal to 42. This is exactly the summation x into y. Now you can guess what is missing is the summation x and summation y. Okay, and we know how to calculate that. So, and what we have here, and x bar is equal to summation x upon n, y bar is equal to summation y upon n. So this is what we know. Okay, here what we got is this is going to be a. So a is equal to 22 and b is equal to 19. Okay, because what we write is this is right. This we write y minus b, and this we write x minus a. Okay, so that's why we got a is equal to 22 and b is equal to 19. Now we can use this formula for x and x bar and y bar. So we have, what is x bar? X bar is a plus summation x upon n, and we know y bar is equal to b plus, okay, summation y upon n. So we got here summation x upon n is equal to a plus summation small x upon n, and we have summation y upon n is equal to b plus summation small y upon n. So please be careful for the notation. It is very important. You cannot write both to be small x. Okay, and if it happens that you write both to be small x, then a becomes 0. But we can see a is not equal to 0. Here also b will become 0. We can see b is not equal to 0. So that's why we have to be careful for writing this all. Okay, and hence what this is going to be summation x. So summation x is going to be 225, and this is going to be 10. This is 189 and 10 we can have. Okay, so this is going to be 225 by 10 is equal to a. So plus, and this is x upon 10. Okay, and we have, this is 189 by 10 is equal to 19 plus summation y upon n. N is going to be 10 here. Okay, so that's what we have. So please check all the values. Okay, so a is 22, b is 19, and this is going to be 225 and 189, and that's what we have. Now we simplify this. So it's going to be 225 is equal to 10 times 22 plus summation x, and this is 189 is equal to 10 times 19 and plus summation y. And so solving this, you are able to get summation x and summation y. So please calculate what is the value of summation x and summation y, and give me these values. So what value you get? Okay, that's great. Okay, that's good. So many of you have got the value. Good. Okay, so we got the value, and hence we proceed further. Good, Ramesh. Okay, So we got this is going to be 5 and this is going to be -1. So I got the value of summation x and the value of summation y. Now what is the term here we have? So we can write the coefficient of correlation, R, between x and y is given as here r is equal to n times summation xy minus summation x into summation y upon square root of n times summation x square minus summation x square, then square root of n times summation y square minus summation y and square. Okay, so create the values here. So this is n is going to be 10 here, and you can see these values here. Okay, so which are given. So what value we want xy? So it is going to be 42. So we got this is going to be 42 minus this is 5 minus 1, and here we have square root of 10 times this summation x square. Okay, so what is summation x square? It's going to be 85 and this is going to be 25. Okay, so we have this is 85 and 25. 85 minus this is 5 square, and here we have 10 times 25 minus 1 square. Okay, so this is the value of r. Okay, so that's what we have. Yep. Okay, that's great. Okay, now give me this value. Hey, very good, very good. So you are good enough now to calculate everything in a faster way. Great. It's good. So it is going to be 0.9376. Great. Okay. So we have this is 0.9376. So it's going to be 0.9376. We got the value r is equal to 0.9376. We are here, and we can say is the coefficient of correlation between x and y. Yeah. Great. So we got this one. Good. Okay. So is there any doubt in this kind of examples when we have the process data? Process data is much more easier than the unprocessed data, because in unprocessed data we have to calculate all the table. Here process data is already, we have to calculate few terms and then we are done. Okay. So is there any doubt in these examples? No, that's great. Okay, so let's go for the rank correlation coefficient then. Okay, that's good. So we have seen the formula to write this rank correlation coefficient. And we have seen that this is going to be the capital R. So we denote it by capital R. And then what we know is we know about the value of this capital R. Okay. So the value of this Spearman's rank correlation coefficient. The value of R is between -1 and 1. Okay, so that is what we have, -1 less than or equal to this capital R, and less than or equal to 1. So this is a very important thing that we need to get, or we need to understand. So the value of this capital R is also in between -1 to 1. Okay. Now I hope you have written this formula. Okay. And then how we are going to do it. So what is the procedure to find the coefficient rank correlation coefficient? So we have to follow the steps. So I'm giving you the steps here. Okay, so these are the steps that we have to follow. Okay, so what we have to do is we have given the x data and y data. Then we write the formula to find the Spearman's rank correlation coefficient. Then we prepare the table with x, y, R1 and R2, or we can say this is the rank of x and this is the rank of y. And then we calculate the differences between two ranks, and then we calculate the square of these differences. And then we use this square of differences to find the value of R. Okay, so here we have to use this formula. So where n is going to be the total number of observations. Okay, so that's what we have. So you please write down these steps. Once you are done, then you tell me. We'll go for the example. So once you are done, you tell me. Then we'll go for the example. Are you done with this? Okay. Okay. So if you are done, then we'll go for the example. Rudrans, are you done? Yeah. Okay. So that's great. So let's go with the example. We'll have an example here. So we have a question that from the following data, calculate the Spearman's rank correlation coefficient. So what we have to do is we have to understand the question, because you will find this correlation coefficient between x and y common. Okay, so only thing is that whether it is Spearman's or whether it is Carl Pearson's. Okay, so what is the key? The key is rank. Okay, so if it is said rank, then use capital R. If it is said no rank, means if there is no word rank, then find small r. Okay, so this is the key for the solution, what you have to find. Okay, so we go with the solution. What you'll be having, so we have let capital R be the Spearman's rank correlation coefficient between X and Y. Okay, and then how it is given by, so we have capital R is equal to 1 minus 6 times summation ei square upon n cube minus n. So let this equation 1, this is the formula that we have. Okay, and now for this we need to write what these terms are. Okay, so what we write here, where, okay, so di is difference between the ranks of X and Y. And what is n? N is number of observations. Okay, so what we know is here n is equal to. So what is the value of n here? We can calculate this, count this entries. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the 10 entries. So 10 observations are there, and that's why the value of n is going to be 10 here. So n is 10 here. Okay, now what we have to do is now consider the table. Okay, so we consider the table. This table is much more easier than the previous one. Okay, so what we have here, see, we are having X data. Uh, to make it, so we have to consider the table here. What are the columns we'll have? Okay, so the columns are, we are having X data, we are having Y data, we are having rank of X, so you can call it R1 also. We are having rank of Y, so you can call it R2 also as given in the formula. And we are having DI, the difference between RX and RY. So it is R1 minus R2. And then what I want a square of this DI. Okay, so that's what we want. Now we have to make a table here early. Okay. So can I have this? So please make this table properly so that you will not have any trouble for calculations. Okay. And write the values of x and y. We are interested in only sum here. Okay. So you have to make this table. Okay. Now see, we have to write all these entries here. So we have 39, 59, 23, and 45. So this is 39, 59. Okay. We have 23 and 45. 23, 45. What about the y entries? So this is going to be 53, 38, 73, 53, 38, 73. Then what do you have? 61, 78, 63. 61, 78, 63. Then we have x, 36, 47, 36, 47. Then we have this is 53, 18, and 63. 53, 18, and 63. So here we have only 9 entries. So we have to change this one. Okay. Now see what is remaining: 48, 83, and 41. So 48, 83, and 41. Okay. How we can remove this? See here we don't want summation x or summation of rank. We are interested in only summation of di square. Okay, so that's what we got. Now we got this one. Okay. So let us see how to assign the rank. So about the rank, I have given you the idea that maximum marks better rank. Okay, so that principle I am going to follow here. Okay, so maximum rank, maximum marks and better rank. So who is maximum in this X series? So you can see what is the maximum here. 63 is maximum. Okay, so you can have one rank to this 63. Then after 63 we have 59. So its rank is going to be 2. Then after 59, what we have? 53. So rank here is going to be 3. Then after 53, what we have? 47. So it is 4. Then 45. So it is 5. Then after 45, what we have? We have 39. So this is going to be 6. Okay. So this is going to be 6 here. Okay, and now after 39, what we have? We have 36. So this is 7. After that we have 23. This is 8. And the last 18. So this is 9. Okay, so one thing you need to remember, the maximum rank is equal to the number of observations. So we have, you can see we have 9 observations here, and then we got the maximum rank to be 9. Okay, and now similarly we have to do it for y. So what is the maximum value of y we have? So you can see the maximum value is 83. So this is going to be the rank 1. Then after that we have 78. So we have rank 2. 73, rank 3. Then what we have after 73? 63, rank 4. Then 61, we have 5. Then after 61, what we can have? 53, 6. Then after 3, we have, this is 48. So it is going to be 7. Then 41, this is going to be 8. And then last 38. So it is going to be 9. Okay. So have you got how I have given the rank? Maximum mark, better rank. Okay. So this is the principle that we are going to follow. Okay, so maximum mark will get a better rank. Better rank means we have to start with 1, 2, 3, 4 onwards. Okay, so rank is in ascending order, whereas the marks we are arranging in descending order. Okay, so that's why one line you should always keep in mind: maximum marks, better rank. Okay, so are you getting how we have given the rank? You got the idea how we have given the rank? Yes. Okay, that's good. Now let us calculate the remaining table. Okay, so we have now we are once we are done with the R1 and R2, the ranks we have calculated. Now we have to calculate the difference between the ranks. So here the difference is going to be 0. Here it is going to be -7. This is going to be 5. This is going to be 0. This is going to be 5. Okay, and here it is 0. This is -4. This is 8, and this is -7. So these are the differences in the rank. Now square this. So we have 0, 49. Then this is going to be 25, 0. This is 25, 0. This is 16. This is going to be 64. And this is 49. And the last we want summation. Okay. So here you please make the summation and then tell me what the value you are getting. So have this summation and give me the value. Yeah, it is going to be 228. That's good. Okay, great. Okay, so you got the idea. That's good. Okay, so it is going to be 228. Okay, so that's what we got the idea now. And hence, once you know the summation, then we are able to use the formula. So what we can write is from equation 1. So we write here from equation 1, we have, so capital R is equal to 1 minus 6 times. So this is summation, and here you will be having 9 cube minus 9. So please calculate this value. What is value you will get? What is the value of capital R now? It's going to be minus 0.9. Okay, it's good. Okay, so we get is going to be minus 0.9. Okay, and hence what we get here? So we can say hence R is equal to minus 0.9. So is the rank relation coefficient between X and Y. Okay, so from this, what we are able to get is, okay. So see here, we got value to be minus 0.9. Okay, minus 0.9 means what? Suppose these are the marks given to the 10 contestants. Okay, by 2 judges. Okay, so if I consider these are the marks given by the 2 judges to 9 contestants. Okay, then that means these 2 judges have completely different liking. Okay, so we can say their liking about any quality is totally different. Okay, and that's why we cannot say that this is going to be a good decision. Okay, so whatever the rank given by them shows that the rank correlation coefficient is very negative, and it negative means it is close to 1. So minus 0.9 means it is very close to 1. So they have the completely different liking, okay, or their judgment is completely opposite, and that's why we should not trust this judgment. Okay, so we should have a second opinion. Okay, so that is what the significance of this capital R is. Okay, so do you have any doubt in this example? Okay, so that's good. You don't have any doubt. It's great.